It's time for the Unit 3B Study Guide Solutions video. Before you watch this video, make sure you've completed the study guide beforehand so you can check your answers to see how prepared you are to pass the unit exam. So with that reminder, let's begin. Number 1 says circle all of the exponential functions below. Anything with an x as the exponent is going to be exponential, so that's going to be the first one and the third one. Next we have to fill in the table for the exponential function 5 times 3 to the x. Our domain is going to be 0 and 2 and 4.1. We're simply going to put those values in for x. So I'll show my work off to the side. This is going to be 5 times 3 to the 0. 3 to the 0 is 1. 1 times 5 is 5. I'm next going to put in 2, so 5 times 3 to the second power. 3 to the second is 9. 9 times 5 is 45. And I haven't needed a calculator for much yet in the course, but this one I really do. This is 5 times 3 to the 4.1 power. I'll do 3 to the 4.1 power on my calculator, multiply it by 5, and this will give you 452.03, rounded to hundredths as it says. Next, complete the table for the exponential function that you see. The exponential function, since it's exponential, we're multiplying or dividing. That's the tip-off. So from 5 to 15, we're multiplying by 3. So 15 times 3 is going to give us 45. 45 times 3 is 135. And 135 times 3 is 405. Next, we want to fill in the table using the domain of 0, 1, 2, and 3. And then we're going to make a graph. So 0, 1, 2, and 3. For the function 2 to the x, it'll be 2 to the 0, which is 1, 2 to the first, which is 2, 2 to the second, which is 4, and 2 to the third, which is 8. Now that gives me ordered pairs 0, 1, 1, 2, 2, 4, and 3, 8. So I'll come over here, and I'll put those points in. So 0, 1, 1, 2. And you'll notice again that the graph goes by half units, so 1, 2 is actually going to be right there. 2, 4, and 3, 8. So our graph is going to look something like so. It's going to follow the x-axis, but it will not cross it. Next item, number 5. The number of bacteria present in x hours is represented by the function shown. How many bacteria are present in 3 hours? To find that, we're going to say y is equal to 3 times 2 to the third. 2 to the third is 8. 8 times 3 tells us we've got 24 of those bacteria. And finally, number 6, given g of x is equal to 5 to the x, the value of g of 3. Well, this is function notation, so that means since we've got an x right here, g of x, g of 3, 3 is x, so 5 to the third power is 125. What domain gives a range of 1 for g of x? That means what x value are we looking for that will give us a y value of 1? Well, 5 to what power is 1? Well, the only thing that can be is 0. 5 to the 0 is 1. That's what we're looking for. Let's keep going. Question 7. Next page. Match the graphs to the types of functions. Types that you can use are linear, exponential, and the quadratic ones. This first one is an exponential. I'm just going to put, for the sake of time, exponential. The middle one is quadratic. That's a parabola. And the last one is definitely linear. That's a line. Let's keep moving. Tell whether each function is linear, exponential, or quadratic. So the first one, x has a power of 2 on it. That's the largest power, so that's quadratic. The next one is exponential because we've got x in the exponent. The third one is also exponential, same reason. The fourth one is linear because we've got x to the first power. And the last one, we're going to put an n for none of them because we've got x to the third power. That's actually called a cubic function. So next, write a quadratic function, and what's true about all of them? Well, here's the easiest quadratic function we could probably write. Y is equal to x squared. What is true of all quadratic functions? The largest power on a variable is 2. Now write an exponential function. Well, we could write something like y equals 5 to the x. And what's true of all exponential functions? Well, what's true is, just like the name says, the variable is in the exponent. So now, let's take a look at the tables here. See what we can figure out. Decide if the tables represent linear, exponential, or quadratic functions. So we got to look at the patterns. So 2, 6, 18, 54, 162. Now, not trying to trick you, so the domains, the x's, are always going to be the same here. Looks like right now. So it looks like we're multiplying by 3 every time, and that's going to make it exponential. Let's go below it to 12. Negative 2, 0, 2, 4, and 6. Looks like we're adding 2 every time. That's going to make that one linear. 13 to the top right here. 256, 64, 16, 4, and 1. Now remember, you can divide each of these terms out, or numbers out, and see if what they have in common. And in this case, we're dividing by 4 every time. So that's the same as multiplying by 1/4. That makes it exponential. Finally, 14, 8, 2, 0, 2, 8. Well, that's nice. They kind of are the same. We subtract 6 and subtract 2, not linear. 8 divided by 4 is 2. 2 divided by 4 is not 0, not exponential. So the only other option is quadratic. Let's see. From 8 to 2, we are going down by 6. Then down by 2, then up by 2, and up by 6. Now to be quadratic, the second set of differences have to be the same. Let's see if they are. From negative 6, I'd have to add 4 to get to negative 2. From negative 2, I'd have to add 4 to get to 2, and add 4 to get from 2 to 6. So our 14th one, a little hard to see for you, I'm sure, is quadratic, and that's the reason why. Next page, 2 schools are tracking how many students are coming down to the flu. The data for each school is shown below. School the north, school the south. The school the north data appears to be linear because we're adding, it looks like as the x's go up by 4s, the y's are going up by 6s. So that is definitely a similar rate of change every time. Now, the other one, just from looking at the shape of the graph, that's going to be exponential. It's definitely not a linear graph. Definitely not a quadratic graph. So which school would you predict to reach 200 infected students first? I would say the school of the south. Because the numbers, because it's exponential, it's growing faster. Explain how to get from one term to the next in an arithmetic sequence. We are going to either add or subtract. Remember, we would have one of those common differences. The general explicit formula is a sub n is equal to a1 plus or minus d times the quantity n minus 1. 17, geometric sequence. This is where we're going to multiply or divide. This is where we have a common ratio, so a sub n is equal to a sub 1 times r to the n minus 1 power. 18, next two terms, we appear to be subtracting 7 every time, so subtracting 7 gives us negative 36 and negative 43. 19, the first term of an arithmetic sequence is 7, the common difference is negative 3. What are the next four terms? Well, 7 is the first term, so we want the next 4. So we're going to subtract 3 from 7, subtract 3 from 4, subtract 3 from 1, subtract 3 from negative 2. There they are. On 20, is it arithmetic? The answer is yes. It's arithmetic because we are adding 6 each time. 21, is this sequence arithmetic or geometric? This one is arithmetic. The formula is a sub n is equal to the starting number, negative 6. We're adding 3 every time, times n minus 1. If we want to find the 75th term, a of 75 is going to be negative 6 plus 3 times 75 minus 1. And I believe we're going to get an answer of 216 for that. 22, if you plot an arithmetic sequence, what shape would your graph make? It's arithmetic, so this is going to be linear, or it's going to make a line. That's the shape. 23, a stock on the New York Stock Exchange began the day at 9 at 42.30. The price of the stock dropped 20 cents per hour and you sold it at 2. What's the price of the stock when you sold it? Well, if you take 20 cents off at 10, 11, 12, 1, and 2, it's going to drop $1. So you're going to sell it for $41.30. The formula for this explicitly is a sub n is equal to $42.30. Common difference, we're dropping 20 cents an hour times n minus 1. 24, write an explicit formula for a geometric sequence. So that means we're multiplying or dividing, where the first term is 2 and the common ratio is 5. So this would be a sub n is equal to 2 times 5 to the n minus 1. Now to find the first three terms, I'm given the first term, it's 2. If the common ratio is 5, I'm multiplying by 5, so that'd be 10. By 5 again is 50. 25, given the sequence 7, 11, 15, 19, 23, write the recursive formula. So the first now is 7. And to get to the next number, I'm going to take now, and it looks like I'm adding 4 every time. That's it to the recursive one. 26, the last one, the sixth term of a geometric sequence is, we've got to find it, given the fourth term, and a ratio, common ratio of 5. So if the fourth term is 10, that means the fifth term we would find by multiplying that by 5. And the sixth term would multiply by 5 again. And that's 250. That's the end of the study guide. If you have done very, very well in the study guide, you're ready to take the exam. If not, go back, read through your notes, watch any videos, do any more practice that you need to get yourself ready to pass that unit exam the first time. Good luck to you.